and welcome to this session on refactoring strategies for .NET applications as you move to the cloud. My name is Tom Moore, and I am a senior developer advocate here at AWS. I'm joined by my colleague.
Hello, everyone. Welcome to today's session. My name is Ronit Vashisht. I'm a solutions architect on a team called Microsoft Specialist. And in this team, we help customers run their .NET and SQL Server applications on AWS. We have a jam-packed agenda today. Couple of demos and a lot of content. We may not be able to take questions during this time, but happy to stay back and answer any of the questions after that. Back to you, Tom.
Right. Back before coming to AWS, I worked as a developer for about 20 years or so, both with software companies and consultancies. Now, all software, if it lives long enough, gets to the point of needing to be refactored. I mean, technologies change, practices change, pretty much change is the only thing consistent in this environment. Ernie, what's the worst refactoring job you ever had?
For me, I would say a code which my team inherited, which exchanged hands, I guess, over 3 or 4 different teams over the period of, 10 years. And we were told to refactor the application and make it cloud native. And nobody knew what the application is doing, what different layers, how they're talking to each other. So it was a lot of fun. How about you?
Well, for me, it was being asked to refactor an application I had written 10 years beforehand and hadn't had a single update. We're talking .NET 3, MVC 1, yeah.
Sounds like fun as well.
Oh, it was worse. I had lost the source code and had to recreate it from scratch.
Oh, my God.
So this is what we're going to talk about in the session today. We're going to cover the 7 R's of moving applications to the cloud. And this is kind of what we look at as solutions architects when we have a catalog of applications. We're then going to introduce the application we're going to use for this session. It's a media catalog application. Then Ronit's going to jump into our first refactoring strategy, which is refactoring an application and moving it to .NET 6. So we're starting from .NET Framework 4.8 here. I'm then going to cover the second refactoring strategy we're going to talk about, which is refactoring into microservices, so pulling some functionality out of an existing app. And then we'll look at what the future state is and where we can go from there. Now, when we talk about moving catalogs of applications or migrating catalogs of applications to the cloud, they all basically fit into one of these seven R's up here. You can relocate, so you basically take the virtual machine and bring it up into AWS. You can rehost, so you take the same application and deploy it natively into AWS, maybe on EC2. You can replatform, so kind of the same thing, but maybe I'm replacing self-managed SQL Server with like RDS, something like that. You can repurchase. So in some cases, the COTS applications you're using, they're available in the marketplace. You just one-click deploy, job done. You've got retain. Sometimes you don't want to actually move the application. Maybe it doesn't make sense. Maybe it's going to get a short runway before you're retiring it, or it's going to have a major rewrite. You've got retire. So maybe you've got an application that's just hanging around because it always has been and nobody's bothered to turn it off yet. And then you have refactor. So refactor is the idea that we're leaving the application fundamentally the same as far as the users are concerned, but maybe we're changing some of the underlying technology to adapt to cloud native functionality. So maybe we're implementing auto scaling. Maybe we're trying to reduce the costs, things of that nature. This is typically driven by a business desire. So along those lines, we have here introducing the media catalog application. This is an internal application, as evident by the fact we spent exactly $0 making it look good. In all seriousness, though, this is actually a sample application we created this year, and it's designed to help people interact with AWS recognition. So if you want to learn how to incorporate recognition into an app, you can download this. That's why we have the link there and the QR code. So our marketing department uses this, not AWS's marketing department, but our fictitious company here. They use this to upload images that they may use for marketing and promo materials. and they'll figure out what's in the image. It's a .NET 4.8 application. Now, if you download it, it's actually available in 4.8. It's also available in .NET 6, by the way. And it's your typical monolith architecture. In fact, here's the architecture. Everything runs on a single EC2 instance in this case. We're using DynamoDB to store some of the metadata about the images that we upload, because it just sort of makes sense. Dynamo is a good candidate there. We're using Amazon Recognition, and we're actually using two functions out of Recognition. The first is we're using moderation. So it's functionality to determine, is there anything potentially offensive about the images we upload? And then the second one is the functionality to detect what's actually in the images, so that we can catalog them and find out later on. Maybe we find the images that we're looking for. We're storing all the images in Amazon S3 because that's a great spot to store all your images in, and we're exposing them to the world via CloudFront because we never want to make our buckets publicly accessible, right? Seriously, please don't ever do that. Okay, so I'm going to show you the media catalog real quick. There we are. As you can see, it looks pretty much the same. You've got some basic functionality. You can upload images here. We've got a list that we can process. I've got some images that I've already uploaded. The process functionality basically goes off to Recognition and says, look at this image and tell me what you think you find in there. Now, most of these are pretty reasonable. Oh, it's sea life, it's an animal, it's a fish. It's either a stingray or a manta ray. I don't know which. I'll call it a stingray. But sometimes you get some entertaining values, like Recognition thinks if it's a bird in there. I don't know. And yes, there are pebbles. And we can hit save. And then if we've looked at an image previously, you might recognize this chap. You can see we're able to save labels against the image. And if we want to browse, we can get a list of labels we've seen, and we say, oh, well, we're looking for images of people, and we've uploaded two images of people. So, very simple application, but it's there to illustrate the use of Amazon Recognition. So, all right, and with that, I hand it over to you, Renee.
Thanks, Tom. All right, so we just saw media library application in action. Application is working just fine. It's getting the job done. Application uses DynamoDB on one side to persist data storage or as a data storage, and then Recognition as a service for image recognition. Both of these services are scalable serverless services. But if you remember the application layer, it is a standalone EC2 instance. Again, it is working just fine, but over the period of time, as the application usage grows, or as the application functionality and features grow, this kind of application is bound to run into some of the challenges. These challenges could be either business-related challenges, or these could be technical challenges. Let's quickly review some of the challenges. So first one are some of the business challenges. The first thing is, as we saw, if the application has variable workload or a variable load across different time of the day or different days of the week or the month, application is not elastic enough to auto-grow and then auto-shrink once the load comes down, which means you always have to provision for applications for the peak load capacity. Even if you try to use elasticity, scalability in your application using auto-scaling service, remember this application runs on .NET Framework on Windows platform. So even if you put this application in auto-scaling behind a load balancer, auto-scaling with Windows instances can take some time. Windows instances can take few minutes to come up, become ready, and to serve traffic. So if your goal is to become really elastic, become really scalable, maybe this pattern will still not work for you. The third one is, if your goal is to adopt deployment automation and modern software deployment practices, such as rolling deployments or blue-green deployments, it is not going to work with this architecture. This is a standalone application. Every time when a new deployment is going to happen, you can potentially run into availability issues with the application. The same thing is true if there is any underlying issues with the EC2 hardware. Because it is a single application running on a single server, you can run into availability challenges in that case as well. The last business challenge here is if you consider all of these things, and if you design your application infrastructure for the peak load, you will end up running multiple EC2 instances or a really big one EC2 instance, keeping in mind the peak load. If there are multiple instances, you'll put them behind a load balancer. But what's going to happen is you will end up having a lot of compute capacity which is unused. And also, since this application runs on Windows, along with the compute capacity, you will also be paying for Windows operating system licensing cost, either directly to Microsoft or to AWS through license-included instances. So the cost is going to be a big constraint, maybe not now, but over the period of time, as your application grows and usage grows, this can become a business challenge. Let's look at some of the technical challenges. The technical challenge with this application is built using .NET Framework 4.8. As Tom mentioned, this application was built for on-premises, but now after moving to cloud, database has been changed from SQL Server to DynamoDB, but the application still runs on .NET Framework 4.8. And in 2019, Microsoft announced .NET Framework 4.8 is going to be the last major release, which means if this is going to be your line of business application and you plan to make enhancements and do feature improvements, you may not be able to take advantage of new features which are coming in latest version of .NET. The next technical challenge is the code base of this application is monolithic in nature. Nothing wrong with monolithic application, but as applications grow, as functionality grows and features grow, application's complexity would grow. Which means if you are going to make frequent changes to the application, you still have to test the whole application every time when you make a change. Scalability, again, becomes a challenge. You cannot scale parts of application separately from rest of the application. So your whole application has to scale. And Tom is going to go into a little more details around monolith versus microservices architecture patterns. Then, if your goal is, again, as I mentioned, to increase the innovation velocity, release frequently, iterate frequently based on your customer feedback, you will not be able to do it with the current architecture pattern. So if your goal is to adopt DevOps practices and automation around it, it will become really very challenging when you're running virtual machines, and even more when you're running a single virtual machine. All of this coming together, the fact that application is not elastic, it cannot scale out and scale back in, application has a dependency on Windows operating system, all of these factors will come together and contribute to the overall cost of ownership. You might think cost is perhaps not an engineering or not a technical, I would say, challenge, but that is debatable. That is why cost is in both the areas. From infrastructure perspective, you can optimize cost to some extent, beyond which you have to think from architecture perspective. You have to think about some of the refactoring strategies that we're going to talk about today as well. So speaking about refactoring strategy, the first strategy that we want to recommend, which can help you with some of these challenges, is porting your application from .NET Framework to .NET Core, or should I say just .NET. Why should you consider following this refactoring strategy, or why our customers are following this strategy? The number one reason is, as I mentioned, that .NET Framework 4.8 is the last major release in .NET Framework. And in 2019, Microsoft announced that all feature enhancements are going to happen in the newer version of .NET. And hence, if your goal is to keep on innovating, keep on building new features in your application, and keep taking advantage of new features which are coming with .NET, it makes sense to port the application from .NET Framework to .NET Core, or just .NET anyways. The second thing is, if you port your application without affecting the external or even internal functionality of your application, you get few advantages out of the box. The first one is performance improvements. Tech Empower benchmarks are telling us that with every new release of .NET, the performance of .NET is getting better as compared to the previous version. Which means just by porting your application to the latest version of .NET, you obviously get performance benefits that comes along with it. And performance benefits, if you think about it, they also translate into cost savings. If your application can work better with less resources, then of course, especially with cloud, you need less resources and you have to pay less to AWS for those resources. So that's an obvious, no-brainer advantage that comes along with it. The second one is now your application is running on .NET 6, perhaps, the latest version of .NET, long-term supported. And by the way, the latest version is .NET 7, which came out early this month. But for the sake of this discussion, I'm just going to refer to .NET 6 because it is a long-term supported version. So now your application is, let's say, ported to .NET 6. You're getting better performance as compared to the previous versions of .NET. One more inherent advantage that comes along with it is your application is now platform agnostic. With .NET Core and all the future versions after that, .NET can now run on any platform, meaning it can run on Windows, on Linux, and Mac operating systems. So by porting your application to .NET 6, you don't have dependency on Windows anymore, which automatically open avenues to take your application and perhaps containerize it and run it on Linux-powered container services. Why Linux-powered container services and not Windows? Windows containers are great. We have a lot of customers who run Windows containers, but containers were born in Linux world, and a lot of innovation is happening in that open source world and community. Even today, if you compare .NET containers for Linux, they are far smaller as compared to .NET container for Windows. So by going to Linux and going to containers, you get advantage of having small footprint, which requires really less resources, and now you can auto-scale very, very quickly. What you were not able to do with Windows instances, now you can very easily do it with Linux containers. Now, you may say that containers is not a thing, which makes sense. Not every application can be containerized out of the box. So even if you don't containerize it, even if you take the same application and run it on Linux-powered virtual machines or Linux-powered EC2 instances, you still get a lot of advantage. You get the advantage of auto-scaling, which works far better with EC2 Linux as compared to Windows, because Linux instances can come up very, very quickly. Second thing is, even if you're running your .NET application either on Linux containers or Linux EC2 instances, your application or your instances don't have to depend on Windows anymore, which means you get direct cost benefit, which can be as high as 30% of the infrastructure cost, which you don't have to pay for Windows licenses anymore. So another benefit in terms of cost. Speaking of cost and performance, another big advantage of taking an application and re-platforming it for non-Windows platform is you can actually run that application on Linux powered by ARM64-based processors. ARM64-based processors, AWS has a custom-built processor called Graviton, and currently in third generation, we have Graviton processors available across multiple instance families. And in one of our internal benchmarks that we have done for ASP.NET, and this was, in fact, now we even have better information around that. There was a session earlier today done by one of my colleagues around running .NET on Graviton 3. But even from the previous benchmarks, we were able to get 60% better price performance benefits by taking the same .NET application and running it on Graviton processor instances in place of x86-based instances. So all in all, if you see, just by porting your application from .NET Framework to .NET Core, you can take advantage of all of these things. And by the way, one more thing I want to add here. A lot of time we hear from our customers that, hey, we have been .NET developer. We have developed applications always on Windows. We don't know how to manage Linux operating system. We are not Linux administrator, which I think is a fair ask. I myself have been a .NET developer. And the great thing about .NET is you can continue to develop your application in Visual Studio, VS Code, or any other platform on Windows, while you can target your application to compile and run it on non-Windows platforms. You can package your application and then deploy it on non-Windows platform like Linux. And the real power of cloud comes when you actually don't have to manage the operating system. So by using managed services such as ECS or EKS for containers, or Elastic Beanstalk for EC2 instances, or even if you go completely serverless with Lambda functions, you don't have to manage any of the operating system. So even as an administrator, you can focus on high-value work for your customers and focus on developing application, writing features, and releasing as quickly as possible. Now, having said all of this, there are some challenges, of course, when you think about going from .NET Framework to .NET Core, right? Few of these challenges are not all .NET APIs which worked in .NET Framework are compatible with .NET Core or with .NET 6. So there are breaking changes that you have to keep into mind. The second thing is, just like APIs, the same thing is true for NuGet packages as well. You might have dependency on NuGet packages which don't have like one-to-one mapping, or the same NuGet package does not have a version which works in .NET Core or .NET 6. So you have to keep that into mind. The third challenge which our customers tell us that they run into is how to find both of these, how to even know which APIs are going to break, which NuGet packages are going to break. It requires a lot of hit and trial sometimes, and then looking up on search engines, etc. Then even if you find all of this, it requires a lot of manual work. Converting your config files, converting your proj files, etc. There's a lot of manual work which is involved around this one. So how can AWS help, right? What is that we can do for our customers to help? Few of you might be aware, a couple of years ago, we announced this assistive tool called Porting Assistant for .NET. It is an open source tool which runs as a standalone application on any Windows application, or Windows PCs. As a developer, you can download Porting Assistant for .NET from AWS's website at no additional cost. Once downloaded, you can point Porting Assistant to your source code, which has to be copied locally. And Porting Assistant will walk you through a workflow where you start with first scanning the application, and then it generates assessment report for you, and it tells you which APIs are going to break in your choice of .NET Framework, .NET version, and then which NuGet packages are not compatible. And on top of it, it can do assistive porting for you. Not just telling you, it can actually convert few of the things for you. For example, if upgrading a NuGet package is going to help, it is going to go ahead and do it for you. Some of the housekeeping that is required, for example, converting from web config to app settings.config, changing the framework of your proj files, a lot of those things can be done by Porting Assistant itself. Now, keep in mind, this tool is designed to be an assistive tool, and not a turnkey solution. But what it can do is, if you required, or if the porting process required multiple weeks, it can shorten that period to few weeks with all the information and assessment reports that it can generate for you. What are the prerequisites to work with Porting Assistant? Porting Assistant can work with .NET applications 3.5 and above. So if you have applications which are built using 3.5, 4.x version, that should work just fine. You need to have application source code to work with Porting Assistant. So on a developer machine, you can download Porting Assistant and have a copy of your source code, and you should be good to go. It can help you assess your application and then eventually port it as an assistive porting tool to .NET Core 3.1, .NET 5, and .NET 6. What are the platforms that we support? We support porting Windows services and ASP.NET applications. So if you have ASP.NET MVC application, MVC 5, Porting Assistant can help you port it to ASP.NET MVC Core. Similarly, web forms can be ported to Core Blazor. WCF apps, it can do assessment and port to Core WCF. Core WCF is the open source implementation of WCF, in which Amazon was one of the contributors in the open source community. We recently started supporting VB.NET apps as well, so your web APIs, class libraries, and console apps, you can port these applications as well using Porting Assistant. Now, Porting Assistant was a standalone tool, and a few weeks ago, we also announced AWS Toolkit for .NET Refactoring. The goal behind AWS Toolkit is to have similar functionality as Porting Assistant, and even more, but provide all of that functionality within IDE of your choice. In this case, as the name suggests, this is for Visual Studio. You can take the toolkit and install it as an extension for Visual Studio 2019 or 2022. It also works in a similar way. It starts with scanning your application code, do the assessment, generate some recommendations, and then do assistive porting on top of it. Additionally, what AWS Toolkit for .NET Refactoring is also going to do is, it is also going to help you do test deployment. Meaning that imagine you have gone through the process of refactoring the code, porting it to .NET Core, and now you're ready to commit your code in the repo. But before that, you want to quickly test your code. You want to run the code and see how it is running, how it is communicating with the rest of the system. So from within the toolkit, you can actually do a test deployment. It is a very lightweight deployment which takes your application, containerize it for you without you having anything to know about containers. So you don't even have to have Docker files. It will create a Docker file for you. If you have, it's great. If not, it is going to create it for you. And then it's going to create a lightweight container running on ECS Fargate. It can do the testing for you along with your application container. Toolkit also installs sidecar container, which is responsible for log collection and any authentication and authorization processes. And once you have done it, once you're happy with the output, you can go ahead with the next steps. We have customers who tried Toolkit in the past. We have Daria, in fact, he's present in the audience here, and he's from Cloya, who is also our advanced consulting partners who have tried this toolkit and helped customers modernize their .NET Framework application. So I will encourage you, if you have questions, Daria, I hope you don't mind. All right. Now, we talked quite a lot about what should be done, what can be done. Let's see how it is done. Let's look at a quick demo of AWS Toolkit for .NET Refactoring. All right, cool. So how do you start with AWS Toolkit for .NET Refactoring? First is you can go to AWS website, or you can look up AWS Toolkit for .NET Refactoring, and you can click on download AWS Toolkit. It's going to redirect you to the Visual Studio Marketplace. This toolkit is shipped as a Visual Studio extension, so you can go to the extension marketplace and grab it from there. Once installed, okay, let me make sure I'm on the right Visual Studio instance. I have a couple of Visual Studio instances open. Yeah, this is the instance where I want to be. So what I have here is I have opened Media Library, the same application which Tom showed you, which was running on Tom's laptop. I have it open in Visual Studio, and I also have extension already installed. So the way I'm going to start working with the extension is I will go to Extensions menu. You will see AWS Toolkit for .NET Refactoring showing up here. And then I'm going to click on Get Started. So the toolkit is going to, first couple of things that you have to configure. You have to tell what AWS profile or AWS credentials can be used by the toolkit. These credentials will be used to communicate with AWS services behind the covers, to share any of the telemetry or the logs, as well as to communicate with the AWS services. You can either create AWS profiles, or you can use existing credentials that may have been set up for AWS CLI. So once you have configured your credentials, the next thing is choice of AWS region. We currently support 2 different regions, and these are not the regions where your application needs to be deployed. Imagine these are the regions where Toolkit APIs run. So for any communication that Toolkit has to do, it will use one of these regions. So in my case, I'm going to go with US East 2. Now, with that being selected, you will go ahead and click on Next. Now, since I ran this toolkit before as well, it skipped the part, but it is also expected to ask you that what is your preferred version of .NET that you want Toolkit to assess your application for. You can always go back to extensions, click on AWS Toolkit for .NET Refactoring, and click on Settings. And you can always change your preference for the target framework. Like in my case, it was .NET 6, but I can change it to .NET 5 or 3.1 if required. With that being selected, that's pretty much it. That's all you need to get started. You need to make sure that one of your controllers are at least open. That is required to activate the extension. Like in my case, I have opened the controller. In fact, it need not be controller. One of the files has to be open in the code editor, I mean. With that, you are now good to start your assessment. So to start the assessment, you're going to click on Start Assessment button. And now the toolkit is going to go through the process of scanning the code, identify dependencies in APIs and NuGet packages specific to the version of .NET Framework of my choice, which in this case is .NET 6. Now, this assessment can take a few minutes based on the size of your application. The bigger the application, more the time it's going to take. So what I've done is I've already completed an assessment for this application, open in a different desktop. So once the assessment is completed, this is how the dashboard is going to look like. You see some information at the top, which tells you what are the incompatible NuGet packages, what are the portable NuGet packages, what are the incompatible APIs, and what are the portable APIs. All this information, in addition to the numbers, all of this recommendation will be shown in the error list pane here. If you look it down, all the recommendations will show as warnings. Like, for example, let me just double click on this warning, which is shown as, hey, to go from .NET Framework to .NET Core, you have to replace system.web.mvc namespace with Microsoft.ASP.NET Core.mvc namespace. So these are the kind of recommendations which are getting generated. And the best thing is now, because it is integrated with Visual Studio, these recommendations are also integrated with IntelliSense. Now, before I start resolving these recommendations or start implementing these recommendations, I have to also port the application from .NET Framework to .NET Core or .NET 6. So as I mentioned, Toolkit can also help you with assistive porting. So the way it will do is, once I'm happy with the report and everything, I can click on this box. I can either port whole solution or I can port selective projects. Like in this case, what I'm going to do is I'm going to click on port solution, and I'm going to port the whole solution. It is porting is final and cannot be done, so it's going to do in-place porting. So make sure that you have a copy of source code before you make any changes. With that, I'm going to click on port, and now my application is getting ported from .NET Framework to .NET 6. It's not going to fix all the warnings, all the recommendations automatically. I still have to do that. I'd still have to do the replacements myself. But what it's going to do is, we'll see it in a minute. OK, it looks like my porting is successful. I'm going to go ahead and reload the project. So my project is getting reloaded. And all right, so a couple of things. Now my project is loaded. I can right-click on my project, go to Properties, and it will hopefully tell me that my project is now compatible with .NET 6. There we go. So it has updated the proj files. Additionally, it has made few changes to my source, some of my boilerplate code as well. I'll come to this code in just a second, but let me show you what we were looking at earlier. So if I go to my error list, and I remove the errors, and so I'm in home controller. I right-click on my home controller, and I say quick action and refactoring. Now, it's going to just take a minute to make sure that all the recommendations can be pulled from the toolkit recommendations. While this is coming up, if you look at on the right-hand side in the Solution Explorer, you see my bundle config, filter config, and route config has been backed up. So all those files have been removed, because in .NET 6, those files don't make any sense. You see under views, just below views, we have app settings.json has showed up. So my web config is gone, and app settings has come here. And while we were looking at it, the recommendations which were showing under the error pane now, we can see it in IntelliSense. So I can actually use IntelliSense to start making these changes. These are coming from the recommendations which Toolkit generated. So I can go ahead and start making my code changes, start doing my refactoring, only if I can click on it, which for some reason I cannot. Yeah, but you got the idea. I think my mouse is not cooperating here. Similarly, if I go down, you see there's app setting which has come up. My global.as6.back has been backed up. Program.cs, startup.cs has been added. Whatever boilerplate that was needed to make my application work, all of that has been put in place. The next step for me is use IntelliSense and use the recommendations which were generated by AWS Toolkit for .NET Refactoring, and keep on making those changes. Now, I don't want to bore you with making all the changes in place. So what I've done is I've already made those changes in the application. So let me switch to that application real quick. So here's the same application which has been ported to .NET 6. And all the issues, all the warnings are gone now, because I have made those code changes which were recommended by the toolkit. Now my application is compiling just fine, no errors whatsoever. The output window tells me, hey, your compilation is successful. Now I'm ready to check in my code. But the last thing I want to do before that is I want to actually test my application. I want to make sure my application actually works on AWS. That's where the testing functionality or test deployment of the toolkit comes into the picture. What I'm going to do is I'm going to click on Run Test Deployment, and it's going to open a dialog box, which is going to ask me some information about the environment. Like, hey, what do you want to call this deployment as? Do you need an Active Directory? Does this application require an Active Directory? What kind of vCPU or resources do you want to allocate to your application? And the last thing is whether I have a Docker file to go with my application or not. And for some reason, oh, there you go. It took some time. Now, if you look at the top, the first thing is, what is the identity that my toolkit will use to do deployment for me? And the identity in this case is either a profile or the CLI identity. In my case, my toolkit is configured to use CLI, and hence the dropdown is disabled, but you can use a different profile for your deployment. Then where is the application artifact? By default, it picks the path where application build files are or the binary files are, but if you want to put it somewhere else, you can change it as well. Project name, the very first time you have to give the name. I have already done the deployment, so it's asking me what is going to be the project name is, if my solution has multiple projects, this dropdown is going to ask me those different names. Then I have to give a name to the deployment. The reason why this name is required is because Toolkit uses CloudFormation template behind the covers to deploy this application. And every deployment can be made unique deployment by using different deployment name. So in this case, it's going with the default deployment name. Then you need to have an S3 bucket in the same region where you're doing deployment. The test deployment, by the way, is going to happen only in one of those two regions. This is the test deployment, not the real deployment. Of course, your real application can be deployed in any of the regions. But right now, this test deployment is happening in US East 2. So you also have to provide an S3 bucket where the deployment is going to happen. The next thing is, do you want Toolkit to create a VPC on your behalf, or can it use an existing VPC? So that's another option that you can provide from here. Then if your application has a dependency on Active Directory, for example, if your application is authenticating to SQL Server using Windows authentication, then you can check this box and provide your Active Directory name as well. Like in this case, I don't have an Active Directory. My application does not have a dependency, so I'm just going to uncheck it. The last setting is, again, optional setting, which region the deployment is going to happen. Again, this is just a test deployment, a very lightweight deployment of single container on ECS Fargate, which you can control how much resources you want to allocate. Like, it's going to go with as less as 1 vCPU and 2 GB RAM. But if your application requires more resources, you can change it from here. With all of that done, you can click on Test on AWS, and Toolkit will deploy it on ECS Fargate container. What you will get back after the deployment is, let me just show you existing deployments. In case of failure, you will see a message which says your deployment failed, and then some reasons why this deployment failed. You can also look at the CloudFormation template, CloudFormation events, to see what happened. In case of successful deployment, it will give you an endpoint where your application is actually deployed. And in this case, what I'm going to do is I'm just going to click on this endpoint. And you see the same application which was running on Tom's desktop. After going through the whole process, this application is now running on ECS Fargate serverless container. To the end users, there is no change in the functionality. Again, depending upon the complexity of application, you have to take into account whether your application can work fine on Linux, work fine on containers or not. But the point here is the journey from running your application on EC2 Windows to running it on ECS on containers can become very, very smooth with the AWS Toolkit for .NET Refactoring. Now, as a result, what's going to happen is, let me switch back to this one. Now, as a result, this is where we started from. A single instance running on EC2 Windows instance. And now, since my application is ported to .NET 6, even if I don't want to containerize my application just yet, I can take the application and run it on EC2 powered by Graviton running on EC2 Linux. And since this is Linux, I can very easily put this application into autoscaling group, which makes my application highly scalable and I don't have to pay the Windows licensing cost. And since it's running on .NET 6 on Graviton, I'm getting all the benefits that comes with the cost and the performance advantage running on this platform. Yeah, so no dependency on .NET Framework 4.8 anymore. No licensing cost to bear. Cost is coming down, absolutely. And Elastic is, my application is at least partially elastic. Maybe not as elastic as I can make it, but it is far better than how it was earlier. And to walk you with next steps, I'm going to hand it over to Tom.
All right, thanks for that, Ronit. So we've made a lot of progress on the application. We've got it ported over to .NET 6, and generally working a little bit better. But there's still some things we want to address. Now, Ronit's changes have made the application scale better, but we're still scaling the entire thing as a monolith. So, I mean, that's not going to be great, because if one part of the application's getting a lot of use, we're wasting a lot of resources scaling a lot of parts that, frankly, don't need it. There's no way to independently scale any pieces of the application. As far as our deployment, it's still an all or nothing deployment, okay, which means that deployments are going to be slow and they're going to be risky, because we've got to deploy the entire application at once. Still a monolithic code base. So we've got one code base that contains all the functionality of the application. Now, we've also got this bit of functionality. I mentioned before the moderation functionality. Well, we've got part of our organization that wants to take advantage of that. But as a monolith, it's not that easy. I mean, we probably could make it so that people could use this bit of functionality, but it's certainly not the easiest thing to do in the middle of a monolithic app. And ideally, we'd like to operate in more of a DevOps fashion. So we'd like to check the code in. We'd like to automatically build. We'd like to automatically test and deploy. Probably just into test, maybe later on all the way through to production. I mean, that'd be cool. So now we have our next refactoring strategy, and that is refactoring into microservices. Now, as I mentioned, we've got this piece of code that we'd like to be able to take out and expose as a microservice to other pieces of other parts of our organization. So what benefits is that going to achieve? Well, a lot of benefits you can see up here. Essentially, the team that's going to take over the development of this microservice is then going to be able to take ownership. They're going to be able to evolve the application at the speed of the business. They're going to be able to make the changes they need to do. They're going to be able to deploy independently of the rest of the monolithic app. If something goes wrong, they can obviously roll back the microservice without affecting the main application. And most importantly, the microservice can scale independently. So if this other part of the organization starts generating a lot of traffic, we can scale up the microservice. We can add more containers to handle more load without having to scale up the entire application and wasting a lot of resources. However, pulling a microservice out of an existing application is kind of complicated and challenging. I mean, where do you start? Well, in our case, we know where to start because we've got a specific request for functionality, and that somebody wants to use this piece. But in a lot of cases, the starting point's really just a desire to kind of retire technical debt. Now, figuring out exactly what needs to go into a microservice gets challenging as well. You build a new project, you start porting code into it. It's a lot of trial and error. Mostly error, because you're going to copy a bunch of classes in, you're going to build, you're going to test, you're going to find out it all falls in a heap, so you're going to copy a few more classes over, hopefully get it working, and then you got to try to strike the balance between how much stuff you pull in. You don't really want to make a monolith service, you want to make a microservice. And in the end, there's a lot of manual effort involved here. Like I said, you got to build a project, you got to start copying things over, hope you get it all right. So wouldn't it be great if AWS had a tool that was going to do this for you? Well, last year, Ronit and I were here on stage introducing you to the first version of the Microservice Extractor for .NET. Back then, even at launch day, there were customers already using the Microservice Extractor to pull apart their applications and develop microservices out of the monolithic applications. Well, in the past year, there's been a lot of improvements made into this tool. The code coverage is better, we cover more use cases, and now you can even extract microservices from .NET 6 applications as well as your .NET Framework applications, which is good because Ronit's already ported our app to .NET 6. Now, keep in mind, this is an assistive tool. As with the porting assistant, it doesn't necessarily do the whole thing for you. Sometimes there is some additional work involved in refactoring after you've used this tool, but it certainly helps. Prerequisites. So once again, this is a desktop tool, so you're going to need a Windows machine ready to go and use. If you're dealing with a legacy application, so you're looking at C# only, unfortunately we don't do other languages, and it's got to be .NET Framework 3.5 or above. Now, the more recent version of .NET you can get to, probably the better results you're going to have, but you certainly can start going back as far as 3.5. As I mentioned, we do support now .NET 6, so you can extract microservices from your .NET 6 code. And you do have to have your solution file and your source code. So we're not going to try to decompile your DLLs here. Right, so let's have a look at this in action. Go. That's my desktop. So we're going to start up the Microservice Extractor. Okay, now this is a standalone tool. It doesn't integrate into Visual Studio. If this is your first time launching it, you're going to have some setup to do. It's going to ask for a profile. You can see the settings here. It's going to ask for your profile, and it's also going to ask for a couple other things like a working directory, etc. Once you've done that, you're going to come in here to your applications, and you're going to click this button that says Onboard Application. You're going to find the solution file, which I've got here. You're going to give it a name, because everything needs a name. And a description, optional. Down here, you've got some options for MS Build. In most cases, you can probably just leave these alone, but if you did need some specific special flags for your MS Build, you can put them there. You then have the option to provide runtime profiling data. So this can be helpful to figure out what should go together in your microservices. I don't have that data here, so I'm not going to incorporate it, but if you did have the data, you can pull it in there. And we've got this option here to analyze .NET Core portability. So if you were pulling a microservice out of a .NET Framework 4.8 application, this would do similar functionality to Porting Assistant and tell you how hard or easy it would be to port your existing application over. In this case, we don't need it because we've already ported to .NET 6. But it is there. So you can do the process of port first, then extract, or extract first, then port. Generally, you're going to find you get better results porting first and then doing your extraction. All right, then we're going to click onboard the application. Now, this is going to go through and it's going to look at all of the source code for your application. And it does look at it at a source code level. That's why we have to have all the source code and not compiled results. Let's get rid of this banner. Now, this does take a minute or two, not terribly long, which is why I don't have it pre-baked. Always takes longer when you're sitting there waiting for it. Yeah, there we go, success. So the next thing we're going to do is we're going to look here at the dependency graph. And now this app isn't huge, but you can see here there's all the little circles. Those are the classes that have been discovered in my application. Now let's zoom in. Oops, go right way. Now, there is a key down here. You can see the labels that have been added into the classes as you go. So you've got POCO classes, plain old class objects. You've got user interface objects. And you've got potentially data access classes. I don't think we have any showing up in here in this application. You've also got some classes with these little dashed borders. That is where that's where the microservice extractors looked and thought this might be a good starting point for you to extract. So if you have no idea with the source code, you've inherited it, this can start giving you some recommendations based on what we're looking for. Now, I already know what I want to extract, and that is going to be the moderation results. So if I can look through here and I can find what I want to do, I can just start grabbing classes and I can pull these out and start making a group. Yep, you can see there we go, and the results, put it in there. There is also a search window here, so if you have a much larger application, you can start typing in some data. So moderation, for example, and then you'll see things start fading out and getting brought into the forefront to help you find what you're looking for. Next thing I want to do, I want to give this a better name because I don't like group 1. Modify your group name. We'll just call this moderation. Oops. Okay. Now, this is, you can go through and you can create multiple groups if you want to. In my case, I'm only going to do one. Next thing I can do is if I've got this selected here, or I can do a right-click and extract group. I've got a menu here, extract import, and I can say extract group. This is going to help me go through the process of building my my new project for my microservice. So once again, I'll give this a name. Description. Go down a little bit more, and some new functionality we've got that's fairly recent. I can create, the new project can be an HTTP endpoint. So I'm going to deploy this into something that's going to be callable on the network, or I can extract just the code and get a library. So that would, if I wanted to create my own microservice, I can pull the functionality out into a DLL and use that. I'm going to continue with the endpoint. And you've got options here for either use remote calls. So in what's left of my monolith, do I want to make calls across the network? Or do I want to just leave comments in there and call locally? So if I wasn't really confident of the level of functionality that was going to be there, I could leave the calls local. Or I can just go here for use remote calls, and it's going to go into the application. It's going to replace the code and make it to call across the network. At this point, I would hit extract group. Now, I'm not going to do that for two reasons. One, it does take a little while, and probably longer than we have. And two, I want to show you another bit of functionality that just launched last week. Let's come in here, and I want to remove all nodes, get back to where we were at. There's this new functionality called Get Automated Groupings. So once again, let's imagine you've inherited a bunch of code, you have no idea about it. This is going to use artificial intelligence to look through the code and create recommendations for you. Okay, now I'm going to kick that off. That does take a little while to run, so we're going to come back to that a little bit later. Just going to minimize that here. What you end up with after the microservice extractor runs is two sets of folders. One is going to be your extracted service, so that's the new microservice, and one is going to be your modified application code. So that's your residual app. Now, if we were to go back and look at the original source code, you'd see that, oops, where's my mouse? Here we are. What's happened is Microservice Extractor has pulled out the existing classes that I needed to create the microservice, in this case, the moderation functionality. And the code is pretty much the same. Trust me, it is. It's also created a web API that surrounds this, so this will present out to the world the functionality that I need to be able to connect into this application. It's taking care of wiring up everything from the main application, so it can be called over the wire. And here on the microservice, it takes care of marshaling all the calls and the data back and forth for us. So now, I may or may not have additional refactoring that needs to be done based on how successful the tool was. In my testing, in this case, the microservice ended up perfectly fine. It was ready to go. So the next thing I want to do is I can use the toolkit for Visual Studio. Now, this is the AWS toolkit for Visual Studio, not the refactoring toolkit. And I can use some new functionality that came out this year called Publish to AWS. This becomes a very guided approach to your deployments. Okay, I've obviously published a few times. And if you hadn't published anything, you get a view that looks a bit like this. And what's happening is the toolkit's looking at your application and saying, I think these are the likely candidates for what was going to be a successful deployment for you. So here I can go an ASP.NET Core app to Fargate. I can go to App Runner, so that's another serverless service for running your applications. I can go Beanstalk on Linux, Beanstalk on Windows, or I can publish to ECR. Okay? In my case, I've already done the deployment. Once again, it does take a little while to do a deployment, especially because I wanted to go to App Runner. And so it's got to build all the infrastructure behind the scenes. And that takes about 10 to 15 minutes. So I've already done that. And up in my AWS account, I've got the service already running and set up and deployed. So let's jump back here to the slides. Okay, so after taking care of all of that functionality, this is what our architecture looks like. Oh, I've only got 2 minutes left. All right, so we've got all the changes that Ronit made to make the application more scalable, running on EC2 Linux, hopefully Graviton to be cool. And we're running in App Runner, so we make all the calls over the wire. I mentioned the Microservice Extractor team has been quite busy. These are all the things that have gone into the new application. Heuristics-based, I showed you that. That's the icons that are in the nodes to help you pick things out. Artificial intelligence, that will complete in a couple minutes. Probably not long enough for me to show it here. We can now extract web forms. So if you've got old applications based on web forms, we can handle those, as well as WCF. We now have the ability, if we hadn't gone through the process of porting the application, Microservice Extractor can extract and port at the same time. So you can pull out your microservice and convert it to .NET 6 all at once. We have launched support for .NET 7, so that's good. And it used to be that if you wanted the functionality to assess your extracted microservice, you had to install Porting Assistant. You no longer have to do that. All right, I was going to do a quick demo of the residual application calling over the wire, but since we have 30 seconds left, next steps, you probably want to, if you didn't already port your application, finish porting it. You probably want to deploy to containers. Your application could be a container, which will help you there. Takeaways, use Porting Assistant or the toolkit to refactor your apps to .NET 6. Use Microservice Extractor to extract the microservices. Best results, port first and then extract, although you can do it the other way. The toolkit for Visual Studio definitely helps with your deployments. And we've got the landing page there for the .NET resources. A lot of functionality. Here's the bunch of QR codes for the tools that are up there. Right. And with that, in just time, I will say thank you very much. I'm Tom Moore. On social media, I am the Basement Programmer. So there's Twitter, my YouTube handle, and Basement Programmer Podcast, and my colleague Ronit, also on Twitter.
Thanks, everyone, for joining. If you have any questions, we are going to stay back to take any more questions after this. Also available on email or on social media. You can reach out to either of us. Thank you so much for your time.
And please fill out your survey.
Yes, please do fill your survey.